So on this review, we are not necessarily going to do every single problem. I'm going to do the ones that I think look most like what you might see on the quiz. So you're going to need a sheet of paper out, put your 1-1 to 1-3 quiz review or some kind of quiz review at the top and your name at the top of your paper. If you want to open it up on your screen so that you can see it a little nicer, feel free to do that. If we skip one, go ahead and skip it. You don't have to do it. We're going to do most of them. We'll skip a few, but we're going to do most of them, okay? Now, when you go to study for my quizzes, using the review is a great place to start. That's going to cover most of what you need. But I have created a 1-1, a 1-2, and a 1-3 video, so you can go back and watch any of that stuff if you want it as well. They're online, so you can watch those as well. Okay, so let's just start with number 1. I will expect you to do a problem where you have to substitute in on the quiz tomorrow. Okay, so let's do problem number 1. If you see in this little kind of light red font underneath, it does tell you if you need more practice where you can go back and look. So that would be in lesson 1-1. So those do line up pretty much with what we had done in class. So if you want to go back and go, oh, I didn't understand number 5. Number 5 was from this lesson. You can go backwards and look at that lesson, you know. So just those are accurate if you want to use those as a help. So remember, for a problem like number 1, substitution, wherever we see A, we're going to put in -1. Wherever we see B, we're going to replace it with a 2. And wherever we see C, we're going to replace it with a 1/3. So just watch your order of operations, especially when you're plugging in negatives. Parentheses are helpful. So we would get 3 times 1/3 minus 4 times the quantitative -1 plus 2. And then it's just a matter of, simplifying it down as much as you can. That parentheses there, that -1 plus 2 would be the next thing I would look at. So we're going to get 3 times 1/3, -4 times 1. So now from there, it's just a matter of go from left to right. So we have a multiplication. We'll do that multiplication for both the 3 and the 3rd and the 4 times 1 next. Going from left to right. So 3 times the 3rd is 1. 4 times 1 is 4. Our final answer will be -3. Now, I am a teacher that will give you partial credit. If I see your work and you made one little mistake, I'm not going to give you no points for that problem. So you have to, showing me work is to your benefit. If you're a person that jumps right to, oh, well, you did some of that in your head and you got -3, I'm not going to count it against you, but I can't give you partial credit if you miss it. So just to keep that in mind, okay? Now, let's read the word problem number 2. It says the distance that Maurice traveled in 2.5 hours riding his bicycle can be found by using the formula D equals RT. D is the distance traveled, R is the rate, and T is the time. How far did Maurice travel if he traveled at a rate of 16 miles per hour? So all you want to do there is identify what they gave you. They told us that the rate of travel, so our R is 16 miles per hour. RT, they told us up here, was 2.5 hours. Another good rule of thumb, check your units. This is miles per hour, this is hours. They're linked perfectly, so you don't have to do any conversions or anything. But that could happen. It's not going to happen on the test, but just for future reference. The distance is rate times time. We have the rate as 16. We have the time is 2.5, so we do get 40. When you get that 40, make sure that you are putting the units on for any type of word problem that includes units, and that would be a distance. And in this case, because it was miles per hour, this would be miles. So just very straightforward, using a formula, plugging into a formula will be something you will see. Any questions about problems 1 or problem 2? Now let's practice again. 3 and 4 kind of are a repeat. 3 is a substitution, 4 is a formula. Let's go ahead and try them. So let's try number 3. Now, again, this time there's a little bit more to play with when you're plugging in. We have that m is 6. We have that n is -3. We do have some negatives we're plugging in. We do have some powers and exponents and things. So just be careful when you're plugging into those things. So we have 5 minus 6 cubed plus -3 times 6 minus -3. So that's just our initial plugging in. Here's where our n was sitting. Because that was a negative, I always, or almost always, use a parenthesis. Here's where our m was sitting. I plugged in that 6. Since it's a positive, you don't have to use parentheses. You can. It doesn't hurt anything. Okay. Now, if you think about what we have to do here, we have a parenthesis here that needs simplified, and this grouping symbol, that parenthesis there. So let's do that. So we get -1 cubed plus -3. Now, here, technically, that's going to become 6 plus 3 because the two negatives there, that's really like -1 times -3, or the opposite of -3. So that's going to become a 9. Now, so skipping that step, if you looked at that and said, oh, that's 6 plus 3 and wrote that on the page, great. If you said, oh, that's 6 plus 3, I'm going to just turn it right into a 9 without showing the 6 plus 3, those are the steps I'm not talking about. You don't have to show every single thing. But showing your steps along the way, it'll help you to not get lost in things. But again, I try to reward you with partial credit if you start out right. I don't want to take off all the points if you just made a silly mistake. Everybody okay with what we see so far? Now, the next thing I notice is an exponent. So let's do that exponent. -1 cubed is -1 times -1 times -1. Remember, 3 negatives multiplied together, odd number of negatives is going to stay negative. I'm sorry, we can take that off now. And then -3 times 9 is -27. And they're both negative now, so we get a final answer of -28. Now, on the test, or on the quiz tomorrow, I'm sorry, you will have lots of room on this. It was just a page from a book, so luckily you have paper. I don't have a lot of room, but okay. Everyone good with that substitution? Had a little more work to it, I thought, for that one. 4 is a formula one, so very similar to 2. Just the formula is a little yuckier, but let's take a look at problem number 4. It says this is the formula for the surface area of a rectangular prism, so the surface area of a box. How much cardboard would you need to create the box? It's given by the formula 2xy plus 2yz and 2xz, where x is like the width of the box, or I'm sorry, x is the height of the box, y is the width of the box, and z is like the length of the box. So all we're going to do is plug in the values. So we've got x is 2.2, y is 3.5, and z is 5.1. You'll notice you're just doing the 2 pairs at a side because technically the formula is the area of the sides, 2 of those, plus the area of the front and back, 2 of those, plus the area of the top and the bottom, 2 of those. So, okay, so let's plug into our formula. So I'm going to write it here to the side. Luckily, you got some room. So on your paper, I would write out the formula, so then you have it right above, or it's going to be right above where you actually fill it in. So it's going to be 2 times the x times the y plus 2 times the y times the z plus 2 times the x times the z. Now, this paper has a lot of multiplication and addition, multiplication and addition. So we can do these 3 multiplications on our calculator very quickly. So that's the way I would suggest doing it. Let's do the multiplications, and then we'll add them up. Okay, so if you do 2 times 2.2 times 3.5, the first set of surfaces, x and y, is 15.4. And the 2 with y and z are 2 times 3.5 times 5.1 is 35.7. And then we do 2 times the x and z, so 2.2 and 5.1. If anybody was doing this in your calculator, did you guys get what I got? Anybody get what I got? Okay, let's assume it's good. Okay, and now, because it's just straight out addition, we just add the 3 together. So if we add the 3 together, you get that the surface area is 73.54 square units. Now, we don't have information about what kind of units those were. They didn't say it was inches, or we'd say square inches. If it was feet, we'd say square feet. They didn't give us that, so we don't have to use it. Okay. If it includes the units, please include the units. If it doesn't, don't worry about it. Everybody good with using the formula we see for number 4? Okay, so that's a surface area one. Let's do number 5. Let's do a substitution that is a little more difficult. Okay. So we've got this fraction. Now, a fraction bar is considered a grouping symbol. So that grouping symbol we see for the fraction bar, think of, I need the answer for the top over an answer for the bottom. That's the way I kind of think about it when I do that. So every place we see a Q, I'm so sorry, we're going to make it -4. Every place we see an R, we're going to use 3. And every place we see a T, we're going to use 8. Okay. So I'm a person that, I'm kind of a visual learner, so I do tend to use like colors or highlights or whatever. I always have on the table over on the side rulers, colored pencils, graph paper. You feel free to borrow whatever you want. Okay, so anyway, so let's take the values we've got. Q is -4, so that's going to be -4 squared. And then R is 3 and T is 8. So that's the top substitution. I did use parentheses there because we've got that negative that we're squaring and we've got that multiplication. Okay, and then we've got Q and R, -4 and 3, minus 2 times the T value. So anytime you're substituting into a fraction, it is the top, it needs to be simplified as much as possible, and so does the bottom. Now let's simplify the top as much as we can. So we're just going to focus only on the numerator. We're going to get 16 plus 24, and that top gives us a value of 40. Now I don't see 40 over there. B has a number that does go into 40, 10 goes into 40. C has a number that goes into 40, that 2 goes into 40. So I'm thinking, if I had to guess, I'm thinking it might be B or C, but let's keep going to see what happens. Okay, let's look at the bottom. 4 times 3 is 12, so that's -12. 2 times 8 is 16, so that's -16, or -38. Or I'm sorry, -28. Now, I don't see that as an answer option, but that is a fraction that can reduce. What is the biggest number you can think of that would go into 40 and also into 28? Yes. 4. Yeah. If you don't see 4, it's not a bad idea. You can cut it in half and then cut it in half again. That works. So that's not the only way to do it. But yeah, both of those are divisible by 4. Now, it's customary to put that negative in the front or in the top. Either of those locations works. You shouldn't keep it in your denominator. And you get 10 over 7, which is B. So the answer is B. Okay? So there you go. Now, let's say that you did it into a calculator and you got a decimal value. You could just do each one of these, like 17 divided by 6. Does the decimal match what you had? 10 divided by 7 would match what you had in your calculator. Everybody okay with number 5? Okay. Let's take a look at 6 through 9. So we're going to do these kind of together. Let's do 6 through 9. I want to add like 2 extra numbers here. Let's add in -2 and also 5. So we're going to look at 6 numbers really quick. This is going to be super quick. The biggest set, remember, so you want to look over your sets. If you call it the word or you call it the symbol, I'll take either. I prefer the symbol as you get used to those, but it doesn't matter. Okay, real numbers are the first thing you look at. I am going to only include real numbers. So you're going to put a double back R for all 6 of those. Okay, so you're going to put that real symbol. They're all real numbers. The only ones that wouldn't be real if it included that I, remember that complex number, that square root of a -1. We're not going to do any right now that includes that. The next thing you look for, is it irrational or is it rational? I or Q, rational and irrational. Irrational are those square roots that don't work out pretty. Those numbers like pi that they don't act pretty. Do anyone see a square root that's not a good square root on that page? Is there a square root somewhere that's not the greatest square root? It doesn't work out perfect. 50, the square root of 50. That's an I. As soon as you get the I done, you can't go further. It's irrational, I'm done. Okay? Rational is any other kind of number on the number line, so all of these are Q. Now, if it is not a perfect number, that is an integer, a whole number, or a counting number. Remember, the integers are things, okay, so this is a fraction. This is the negatives and the positives. This is 0, 1, 2, 3. This is 1, 2, 3, 4, like we count. Okay. So this is irrational. This is real. Okay. 6 and 7, we're done. 9, we're done. But -2 and 5 are on the list. Okay? -2 and 5 are on the list. You know how much I'm going to get that in a math class? Anyway, 6, -2, and 5 still fit some of our other categories. So just think about the integers. Is it a negative or a positive whole number? So this one's an integer. This one's an integer. Is it a positive integer or 0? Then it's a whole number. So now we're done with -2, but we can keep going with 5. It's a whole number. When you're a little kid, did you learn to count with it? Yeah, 5's on the list when we teach a little kid to count, so it's a natural number. Okay? So, you know, we did, when we first learned about that in lesson 1-2, you can go back and look at your notes. That's why we take notes. So there are going to be a few where I'll ask, what are the sets? And you're using R, I, Q, Z, W, and N. So reals, irrationals, rationals, integers, whole numbers, and natural numbers. Any questions about the numbers which they belong, what sets they belong to? Okay. Now let's talk about the property, like number 10. There are only 3 ones that you have to worry about. Commutative, leave a little space, and then associative, and distributive. Sorry, my associative looks so gross. Associative. Okay. So let me remind you of the 3 ones you have to know. There's only 3 properties I'll ask you about. It's going to be one of the 3. So the answers are either going to be commutative, associative, or distributive. Commutative is like A plus B is the same as B plus A. So if it said 7 plus X is the same as X plus 7, what property is that? You would say commutative. Okay. So if the order changes, commutative. Associative, it would be 3 things, like A plus B plus C, A plus B plus C. But remember, in associative, who you're associating with changes. So like today, A and B are friends, but tomorrow B is friends with C. So it's the association that changes. And then finally, distributed you're going to have something. Sorry, my iPad is really dying. I have a big crack in it. There we go. The distributive property, I'm so talented, is A times the quantity of B plus C. So you have something sitting in front of a parenthesis, you're going to distribute it in. So A is going to multiply times B. A is going to multiply times C, and then you add them up. Okay? So those are the only properties I'm going to have on there. There's only one question. It's going to say, what's this property? You just, it's one of those three things as your answer. So you got a 33.33% chance of getting it right. Anyway, looking at number 10. What property was used in that one? What property was used in number 10? Was it the commutative property, where it switched back and forth? The associative, where the parentheses change? Or distributive, where we took something and multiplied it inside a parenthesis? Which one was it? It's the distributive property. Don't be confused. The 7 can be in the front or the 7 can be in the back. It is the distributive property. So there'll be one of those, a real quick, easy one, okay? There are going to be at least one. I'm looking at the quiz here. Yeah, there's one like number 11, and I think there's another one we can practice too. Okay, if you take a look at 11, it is just applying the distributive property in your simplification. So we've got this -3 out in front, distribute it in, then this +2, distribute it in. Okay, so the first thing you do is use that distributive property. We get -21a plus 12b. Now we're going to distribute the 2, -6a plus 2b. Now once you have the list of terms, always check to see, is there some way that I can put things together? Do we notice any terms that are like terms that we can add together? What do we got? What do we see? Okay, so we got the a's. Now remember, they have to be the same power and the same variable, okay? And so we got the b's. So just use your rules of adding like terms. You add or subtract the coefficient, keep the variable, okay? So -21 and -6 is a total of -27 of the a's. +12 and +2 is +14 of the b's. Everybody good with how we simplified number 11? Okay. Now, I don't care about 12, skip them. You don't even have to write anything on your paper, but I'm skipping 12. Let's do one more. Let's do 13 with that distributive property one more time. So dealing with fractions is important. So I'm going to show you kind of the quickest way to do this problem, even though it has fractions in it. So we need to distribute the 2/3. So think of these whole numbers, put them over 1, and then it's very easy. Multiply tops with tops, bottoms with bottoms. So we're going to get 8 over 3m minus 10 over 3n. Okay, so that's the first distribution. So I just did 2 times 4 over 3, 8 over 3. 2 times 5 over 3, 10 over 3. Okay, we can do the same trick for the back one. Just make this 2 over 1, and that's 1 or 1 over 1. So we're going to get plus 2/5 m, and then plus 1/5 n. Now, just like the one we saw earlier that had like integer coefficients, you still have to do that final trick where we combine like terms. So we still have m's that need to go together, and we still have n's that need to go together. Now look, in our m's, we've got a 3 and a 5. So if you're searching for that common denominator, if there's such unique numbers like that, you could just do 3 times 5, 15. Okay? So let's deal with the m's first. Let's make those have a common denominator of 15. So remember, to multiply fractions, you multiply the tops with the tops and the bottoms with the bottoms. To add or subtract fractions, you have to have a common denominator first. So remember the trick you did back in the day. And you can use your calculator for this for some things, but 3 goes into 15 5 times. 5 times 8 is 40. 5 goes into 15 3 times. 3 times 2 is 6. So again, okay, let me show you. 3 goes into 15 5 times. 5 times 8 is where I got the 40. 5 goes into 15 3 times. 2 times 3 is where I got the 6. Okay. And then you just add up the tops, 46 fifteenths m. And this one here has that 46 fifteenths showing. 46 over 15 can't reduce further. So, you know, if I was doing this multiple choice, I would just circle and say, oh, it's F. But let me show you why we get the correct answer. Let's do the same thing for the ends. Same 15ths for our ends. So 3 goes into 15 5 times. 5 times 10 is 50. 5 goes into 15 3 times. 3 times 1 is 3. Negative 50 plus 3 is negative 47. Okay, so the answer was F. But multiple choice, you know, that's a great thing about a multiple choice, yes.
Before you do that, couldn't you simplify the negative 10 over 3 and the 1 over 5? Because the numerator 10 and 5 are both divisible by 5.
Be careful. So if they were multiplied together, so if it was like 10/3 times 1/5, you could do that. But 10/3 plus 1/5, we unfortunately can't. So remember the rules, and that's a good question. If you're adding fractions or subtracting them, you got to get a common denominator. If you are multiplying, that's when you can kind of do a little bit of tricks where you kind of simplify tops and bottoms a little. Unfortunately, addition and subtraction actually become the harder things for fractions. Any other questions about 13? Okay, let's talk about 14. I will have you give me the additive inverse and multiplicative inverse on the test. So I'll give you a number and you'll tell me both. When we learned about these things, I told you think of this as the opposite and think about this as the reciprocal. Okay? So if it says additive inverse, just think of opposite. If it says multiplicative inverse, think of reciprocal. If you do that in your brain, you're going to be good to go. On your paper, just write the word add for me so I know which is which. The opposite of 7, 6, you just change its sign. So that's an easy one. The multiplicative inverse, you have to do the reciprocal. Now, if it's already set up like a fraction, you just flip it over. 6 over 7. But, I mean, if it's a whole number, just put it over 1, then flip it. Okay? Everybody good with 14? So I will ask you one of those. Let's skip 15. Let's skip 16. Let's jump to 17. I will ask you one verbal expression that you're going to need to translate for me. So let's take a look at this one. It says, which algebraic expression represents the verbal expression, the product of 4 and the difference of a number, and 13. So the product of 4 and something means we're going to multiply 4 times something. It just happens to be, sometimes they'll say the product of something and a sum or a difference. Those words tell us that we're going to add or subtract. Difference means to subtract. And what two things are we subtracting? Well, they called their number n. So just look at the variable they used. It can be any variable. It's just a placeholder for information. And 13. Which one of those matches what I wrote down on the page? Which one of those matches? B. Yeah, the reason that A doesn't match is they didn't distribute the 4 in, you know? So it just wouldn't be right. C would be the quotient of them, the division of them. D, they just kind of misinterpreted what that n and that 13 were doing. Okay, everybody good with that one? Let's take a look at 18. Let's take a look at 18. Let me kind of cut this and paste it so I can have more room. Okay. So in lesson 1-3, we did some equation stuff. So here's an equation that we just need to solve it for x. There are no absolute values on this one. 1-4 is not included. That will be on our next quiz or test, okay? But not the one tomorrow. Okay, so to solve this equation, what I like to think about is I look at each side individually and look and say, is it an expression that I can simplify? Okay. Well, you can definitely simplify this. We can distribute here the -3. We can multiply these two together. So we have stuff we can do to both sides. Okay, let's distribute the -3. We get -18x minus 15. And then we can multiply 2 times 4x. It's just hanging out by itself and make that 8x. Is there still something we can do on the left side to make it simpler? Yeah, what can we do? The like terms. So exactly, yeah, those are both like terms, so why not put them together? We get -10x minus 15 equals 20. So only once both sides have been simplified as much as possible do I look outward and say, what can I do next? So I would probably move the 15 so it's over there with its like normal number little cousin over there. And so we get -10x comes down, 20 plus 15 is 35. What do we have to do to get the x isolated completely alone? Yeah, we got to take that -10 off. And if it's multiplying, the opposite of that's division, exactly. So let's divide by -10. The division by the negative will cancel out the negative and cancel out the 10. So you do want to include a negative there. And we get that x is -35/10. Now, let's say this problem was worth 4 points, and you got all the way there. You're going to get 3 out of 4. But I got to take a point off. Why? What's wrong? What's left? It's not simplified all the way. Simplify it for me. How could we get it nicer? What could we divide by?
5.
Yeah. So I like fractions. I know sometimes you guys don't. But fractions are really a little more algebraic than a decimal. So I would reduce it. And what do you get? Yeah.
I put -3 points.
Oh, okay, thank you. I'll get to that. Okay. So if we do -35 divided by 5, that's -7. 10 divided by 5 is 2. Now, if you put in your calculator 35 divided by -10, and it comes out to be such a beautiful decimal like -3.5, one that ends so quickly, I'm okay with that. I'm not going to take, that's not wrong, you know. So if you do -3.5 for this, yeah, that's fine. What I don't like is, let's say that it would be like thirds and it'd be repeating all gross. I want the fraction because it's more accurate. Okay. Everybody good now with 18? Awesomely lovely, wonderful. Okay. We are going to skip 19, and then we're going to do 20. Let's do 20, and then I think you have everything you need for your quiz. Okay, let's take a look at 20. It says the formula for the surface area of a sphere is 4 pi r squared, and the formula for the volume of a sphere is 4/3 pi r cubed. Find the volume and surface area of a sphere with radius 2, and write your answers in terms of pi. So we got a sphere, so think of a basketball or something like that. And thank goodness that it fixes the circles for me. So if you're in an algebra class, that's how you make it kind of look three-dimensional. So it's a ball of some sort with radius r, so that's that distance from the center out to the edge. So if we think about a basketball, if we could somehow pinpoint the middle of the basketball and measure outward, a sphere is defined as all the points that are equidistant from that point. I think the surface area of a sphere is the craziest formula ever. Think about if we took a basketball and if we somehow could slice it perfectly down the middle and we took a piece of paper and copied what that circle was sliced down the middle. If we took a piece of paper and we did 4 of them perfectly, it would cover the outside of the basketball exactly. Isn't that kind of crazy? Take a basketball, slice it right down the middle. If you can duplicate that four pieces of paper like that, it will cover the outside of the basketball perfectly. I think that's, so, and it's exact. 4 of those, 4 pi r squareds, which is a circle, 4 pi r squareds covers the basketball. I don't know, I think the surface area formula for a basketball or a sphere, crazy. Anyway, weird formula, but it's one of my favorites. But let's take a look at A. It says find the volume and the surface area if we know the radius is 2 inches. So let's put r equals 2 inches as, it's something I do if I'm reading a word problem and they give me that information in words. I'm going to put down what the symbol is because it's just helpful. Now it says write your answer in terms of pi. Now what that means is when we do the work, we're just going to leave the pi in there. So just leave the pi in there. Okay, 2 squared is 4, so we can make that. And then 4 times 4 is 16, and just hang the pi there. And that would be square inches, square inches. Okay, because it is covering a surface. It is covering a surface. So that's why it's square inches. Now let's do the volume. So the volume is 4/3 pi r cubed. 2 cubed is what number? 2 cubed is, anybody tell me? Thank you. 2 times 2 is 4 times 2 again is 8. So that's 8. It's weird how we mess up 2 cubed a lot. It's a very common one that I see students messed up. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. Those are the most common cubes you'll probably use. And then just multiply the tops of the fractions. And tack on a pi. This time it's cubes. How many little cubes would fill up the basketball? Not cover the basketball, that's surface area. But how many cubes would fill up the basketball? Well, this is probably the size of more of a softball, but anyway, okay? And then don't worry about B. Just using the formula, okay? So the quiz is tomorrow. It looks very similar to what you just did. Please, at this time, turn this in and take pictures of it. And then I'll post this video sometime later today, but it'll go in your Google Classroom. It'll go in the playlist for the class as well. So take a picture. Do we have any questions about the quiz or anything in general? Okay. Turn this in, please. Quiz tomorrow.